Welcome back to the class, and this is the third part of atomic theory. If you have not seen the other part, it's better you go to my page and look for it there so that you can understand very well. Now, today we want to learn about relative atomic mass. Sometimes some people usually represent it as capital A, small r. That is relative atomic mass. What is the usefulness of calculating this relative atomic mass? You know, most of our elements are naturally occurring, and you cannot find purest compound, or let me say purest elements naturally. So that means that's why we have isotope, isobars, and isotopes. So if you have, for example, you have an isotope, so for you to get the exact amount of each isotope, you need relative atomic mass. Let's say you have 100% atom of fluorine, and in our last class we said we have fluorine 35 and fluorine 37. So chlorine 37. So how will you get the percentage of each isotope in the 100% of that particular atom? Now, this is what we do. For you to calculate relative atomic mass, AR, or you can represent it as RAM, anyone you like. So it is equal to the percentage. So percentage of that atom, of the atom, multiplied by the abundance. So that's how you calculate it. Then let's say you have for isotope 1, same thing for isotope 2, for isotope 3, and that's how you will continue. Now let's take this for example. Alright, now let's check this question. Calculate the relative atomic mass of neon of masses 20 and 22 with relative abundance of 90.85 and 9.15 respectively. That means the one of 20% will be having 90.85 and 22 will be having 9.15. Now let's calculate the relative atomic mass. For our relative atomic mass, we are using this formula as I've said before. So we firstly write the percentage of the atom, which is 20 and 22, right? So 20% is 20 over 100, right? So 20% multiplied by the abundance. What is the abundance for 1? That is 90.85. Bracket is like this. Then plus we have percentage 22. So 22% multiplied by the abundance 9.15. So when you input this into your calculator, so we have 18.17 plus 2.013, and if you add everything together, you are going to have 20.183. That means the relative atomic mass of neon is 20.183. So I want you to calculate the relative atomic mass of fluorine with masses 75% and 25%, and relative abundance of 35 and 37 respectively, and drop the answer in the comment section. See you guys in the next part.